This is a demonstration of transfer function for iOS by Studio 6 Digital, the dual-channel FFT audio analyzer that includes magnitude, phase, coherence plots, and the delay finder. Transfer function is a two-channel measurement which works by mathematically subtracting the reference signal from the measurement signal. This enables us to do some great advanced measurements, including getting very stable frequency magnitude plots, displaying a phase versus frequency plot, measuring time delays with the system to sample accuracy, windowing out room reflections, and being able to adjust the system EQ with program material rather than having to use pink noise. Transfer function is available as an in-app purchase in the Audio Tools iOS app and is also available as a standalone app. Transfer function can be used in two modes, single channel input or dual channel input. This means that you can use all of the features of transfer function by using iTestMic, iPrecisionMic, or even using the built-in iOS device microphone by using the headset output for the reference signal. Or you can use a true two-channel input device such as iAudio Interface 2 or another USB audio input device. The main difference is that with a single input device, you need to use the internal pink noise generator as a reference signal source, but if you use a two-channel input device, you can use program material such as music for the reference signal. First, let's take a look at using just the internal iOS device mic. Later, we will see how to set up and use a two-channel interface. Since we will be using the internal pink noise generator, we need a way to get that signal out of the iOS device and into the sound system. You will need a cable with an 1/8" 3-conductor plug for the iOS device headset jack with either two RCA connectors or one 1/4" or XLR balance plug on the other end. It's important to set the generator correctly for the cable type. Tap the sign icon to bring up the generator panel, and if you are using the balanced 1/4" TRS or XLR plug, select BAL for balance mode in the generator pop-up panel. Otherwise, select mono. Plug this cable into your sound system and turn on the generator to make sure you have signal. Remember that the iOS device hardware volume buttons also control the headset output level. Now that you have an output signal, the first and most important thing to do is to correct for the iOS system audio delay, which is also called latency. This will vary widely from device to device, but it's easy to correct this. First, bring whatever microphone you are using right up to the front of the speaker. Tap the delay value shown on the top of the iPhone screen, or in this case on the bottom of the iPad screen, to open the delay finder panel. Tap the reset button to make sure any previous results are cleared out. Now turn on the generator and tap Find Delay. It's normal to see a very large delay at this point. Tap Set as System Latency, and then also tap Set as Baseline. Now that the latency is set correctly, you're ready to measure the frequency magnitude plot. Move the microphone back to the listening position, run the delay finder again, but you don't need to set the system latency or baseline. This will give you the correct phase plot and magnitude plot at that location and also show you the delay in milliseconds. Now let's take a look at setting things up with a two-channel interface. We've got iAudio Interface 2 plugged into the iPad with a microphone plugged into the mic input of the interface, and plugged into the line input is the reference signal, which is the same signal that's being sent to the sound system. If you are using another two-channel audio interface, such as those that use the camera connection kit, plug the microphone into the left channel and connect the reference signal to the right channel. With a dual-channel system, the latency is not critical to set up. You can skip this step and go directly to the listening position setup. Since the microphone signal is delayed by the amount of time that it takes the sound to travel from the speaker through the air back to the microphone, we need to compute this delay very accurately for good results. Use the delay finder as described previously each time that you move the position of the mic. Looking at the main transfer function screen, we have the magnitude and coherence plots on the top of the screen and the phase plot on the bottom. Now that we have the delay set correctly, let's watch transfer function in operation. Notice especially how stable the phase and magnitude plots are, even though we're using music as the test signal. Let's have a look at some of the other features available to us in transfer function. The smoothing for the plot can be changed from none to 1/3 octave smoothing. This applies to both the magnitude and phase plots. We also have averaging options that range from a set number of FFTs to fast, slow, or an infinite average, which will continuously sum the FFTs over time. The touch GUI allows you to zoom or pan the frequency or magnitude scale. At any time, you can double tap the display to normalize it. Drag the cursor across the screen to read out the exact frequency, degrees of phase delay, and coherence percent. The value displayed on the top left of the screen is the overall dB SPL from the measurement channel. We can tap it to make it larger on the screen or tap again to make it smaller. We also have the option turned on to display the peak frequency on the magnitude scale. In the lower right corner of the screen, you see we have our 2 dB level meters here for the measurement and reference channels. And if we touch the blue arrow just above them, we get the actual dBFS level as a numeric readout, which is the headroom available in each of those signals. Let's have a look at the setup screen. From here, we could turn the coherence plot on or off, or we could set a specific value for the coherence masking, which is the level of coherence below which the graph is hidden. We also have controls for audio pass-through, difference mode, and for locking the graph scale. The FFT size can be set from 2048 points up to 32K. We can also turn peak tracking on or off, set the SPL readout to A, C, or unweighted, and pick an FFT data window. Even though we have the coherence plot turned off, it will appear while it is being adjusted. We have 2 buttons that control the input sources to the transfer function, measure source and reference source. Tapping measure source brings up our microphone selection screen so that we can pick which microphone we want to use. And when we tap reference source, we get the reference source screen. If you're using the internal iOS mic, there's nothing to set up here. But if you're using iAudio Interface 2, there are several useful options. Next, let's have a look at the save and recall system and transfer function. Tap the folder icon to bring up the Save Recall screen. Type in the name of the file that you'd like to save and tap Store File. When you want to recall that file, tap the folder icon again, select the file, and tap Recall. The recalled file is shown on the screen in a different color, so it's easy to tell the difference between the two. If you're just interested in the difference between the files, select Difference Mode. And now one file is subtracted from the other, and you can see the difference in real time. We've been running this demonstration on iPad, but let's see what transfer function looks like on the smaller screen devices such as iPhone. First, you'll notice that the graphs all appear in one window. This can get busy, so in setup we give you the option to select only magnitude, phase, or both, in addition to being able to turn the coherence plot on or off. Also notice that when I manually adjust the coherence plot marker up or down, the plot appears momentarily as I am doing the adjustment. All of the other features of transfer function are available, including the delay finder, the pop-up generator, the cursor, the touch GUI, and coherence masking. And that concludes our demonstration of transfer function by Studio 6 Digital.